So guys, we were doing dimensional analysis. So this is a equation, and what was being asked, the dimension of A and B. Now, in the significance of dimensional analysis, I told you one of the important thing, principle of homogeneity, which says that variables of the same dimension can only be added or subtracted. So here V was velocity, so we know the velocity dimension. Okay, velocity unit is meter per second, so dimension would be L/t minus 1. So we know the dimension of velocity, so the dimension of every variable here has to be L/t minus 1, and we are going to use that. Okay, so dimension of AT has to be L/t minus 1. Here we know the dimension of T, that is T only, and dimension of A I need to find. So the dimension of A here would become, it has to be T goes to the power of 2, T goes there, so the dimension of A would be this. Similarly, the dimension of B, variable B is not with any variable, so it has to be equivalent to the dimension of velocity, that is L/t minus 1. So thereby I came to know dimension of every variables. So this is one of the significance of the dimensional analysis, which is an easy thing, not a big thing. Now the second importance of dimensional analysis is we can derive formula. I'll show you derive formula. Say for example, I gave you a problem and we analyze the force on a block, and as we analyze we came to know the force acting on the block is directly proportional to mass of the block. Okay, but we don't know what should be the exponent, how is actually dependent on the mass, so we took the exponent as A. The force on a block is directly proportional to the acceleration, but we don't know of what order, to which to get as B. Okay, so thereby directly proportional, so thereby there are two variables, so directly proportional, so we are going to use a constant. Say for example, I use the constant as K, so the final expression has come as this. This is the expression for force. Now I need to find the value of A and B, actual value. For that I'm going to again use the dimensional analysis, the importance of dimensional formula or dimensional analysis, which says that the dimension formula on both sides of an equation has to be equivalent. I know the dimension formula of force, which is M/L/t minus 2, m to the power 1, t to L to the power 1, t to the power minus 2. Now same to the right hand side, the dimension formula has to be same. For constant it's a number, so the dimension formula of that would not exist, but for mass the dimension formula would be m only, m to the power A. Okay, for acceleration the dimension formula is L to the power 1, t to the power minus 2. Now the power of that is ma acceleration to the power B, so whole come B, so it becomes m to the power A and L to the power B, t to the power minus 2B. Okay, now we just need to equate right hand side and left hand side. Left hand side is this and right hand side is this, and equate the power. So see, the power of m here is 1, here is A, so what do you think? A would be equivalent to 1. Okay, the power of L here is 1, here is B, so you can also see that B is actually equivalent to 1 itself. So ultimately what would be the final formula? Force is equivalent to K m times m to the power 1 a to the power 1. So this is the formula, K m1 a1. And from experimental analysis, from experiments, I came to know that the value of K is equal to 1. Okay, we cannot find it. It is found by the experiment. So force comes as mass into acceleration. So this is the formula of force come. And how did it came? We took the help of dimensional formula. Okay, so this is one popular question. I ask you the same, that there's a pendulum. Okay, so pendulum, it does the to and fro motion. So the time period of oscillation of a pendulum, of one oscillation of a pendulum, is directly proportional to the length of the pendulum. Length of pendulum, and that time period is also dependent, okay, over the acceleration due to gravity. Acceleration due to gravity, also dependent over the acceleration due to gravity, directly proportional to the acceleration due to gravity. Find the formula of time period of pendulum. Okay, so we know that it is dependent, is directly proportional to these factors. So to find the solution, I have first used time period is directly proportional or dependent on the length of the pendulum. So I took it power as a. Then second variable upon which the time of pendulum depends is acceleration due to gravity, and I don't know how to what order it depends, so I took the power as b. So now I need a constant, so I took a k as the constant. So L to the power a, g to the power b. Now what I would do, I would use dimensional analysis, and I know that the dimensional formula on both sides of the equation has to be equal, same. Okay, dimensional formula has to be the same. So what is the dimensional formula for left hand side? If I say for left hand side, it is nothing but L to the power t to the power 1. It's only time, so there is no point. T to the power 1. Okay, now come to for the right hand side. For the right hand side, if I talk, so dimension for of k would be nothing, it's a constant. For length it would be L to the power a, L to the power 1 a, and for acceleration due to gravity it would be g is actually acceleration due to gravity, that means acceleration a, and that means meter per second square. L t to the power minus 2 power b, t to the power minus 2 power b. Okay, so L to the power a and L to the power b, t to the power minus 2b. So this is the case, if I'm right. So just see the calculation, L to the power a plus b and t to the power minus 2b. Now let's equate the right hand side, left hand side, because the dimensional formula on both sides has to be equal. So let's equate. So for left hand side it is t to the power 1, so minus 2b has to be equivalent to 1. So what is the value of b here? B come as minus half. And what do you think? A plus b. Let's equate the power of L. Equate for L, equate for t. Equate for L, this has to come 0. So A would come as negative of b, and it has come to half. So thereby, just putting the value here, time period of pendulum would come as k L to the power half. That's when I can write this G to the power minus half. Okay, it's actually L to the power half and G to the power minus half. So minus half goes to the denominator and half of I can replace it with the root. So it's not a big thing. This can be written as L root 2 and this can go to the denominator of that, G root 2. And by experiment, okay, this is only due to experiment. By experiment I came to know that the value of on experimenting, this is due to the experiment. We don't know, we can't know this by by solving something, the value of k. No, by experiment I came to know the value of k is 2 pi. So if you remember, the time period of a pendulum is 2 pi under root L over G. So that is the time period of a pendulum. So that is the answer. Okay, so hereby we had discussed all the things in units and dimension. If you solve the questions of that, you would get a good hold over it. So it's a simple chapter, easy chapter, but it's the starting of those tough things, okay, and a base. So make questions over it. That's it.